Okay, so now we're working on the 4-6 additional vocab support. Remember, put your class period. The left side is showing you a completely worked out proof, and on the right side it gives you other questions kind of related to what's on the left. So the first thing I'm going to do is go through this proof. You're given C as the midpoint of AE and BD, and you're trying to prove AB is congruent to ED. So you would first have this, which is your given. Then, like we said before, if you have a word here, then you're probably going to say definition of that word, and that's what happens. So if this is the midpoint, then these are equal and these are equal. So that's what they did for the proof for the second statement. The other thing is you're given lines are parallel, and so when you're given that, then you're going to probably use your alternate interior most of the time. You have two parallel lines cut by your transversal, so this would be equal to this one from alternate interior. And looks like what they did instead is they used this transversal, so this one would be equal to this one. So these are two examples of alternate interior. It's also telling you that these are right angles from definition of right angle. And then since you have your hypotenuse equal from these equal, as well as some legs equal, then you know your triangles are congruent from HL. And then you go back to what you were trying to prove, which was what these were equal, and there's your CPCTC. Remember, corresponding parts of congruent triangles are congruent. Okay, so that was basically your proof. Now we have some separate questions over here, like what is the definition of midpoint of a line segment? And so it's a point halfway between two endpoints. A point halfway between two endpoints. So first let's do some easy examples. If we have 0 and 10, the middle would be what? 5. Yeah, 5 is the middle. And if you have -3 and +3, what would be the middle? Yeah, 0. Okay, so those are the easy examples. You can kind of just figure it out. The next one's going to be a decimal. I want to do this example from -2 to 5. So you may want to guess and check, but the formula was basically -2 plus 5 and then divide by 2. So this would be 3/2, which is 1.5. And then you can imagine if this is 1.5, this is 3.5 units away to the right and 3.5 units away to the left. 3.5 units to the right and left to get to the end point. So that was just a review about midpoint. Any questions about that? Okay, so then on this one, how do you know that these are parallel and that angle B is 90? Well, on this side it says given, and so it was by reading the diagram. By reading the diagram. And then on the left side, it's talking about the congruent segments and definition of midpoint. Over here it says, what does the symbol mean when it's between two line segments? So that would just be line segments are congruent. line segments are congruent. Congruent and equal basically mean the same thing. It's just they use congruent when you have a bar above it, like calling it a line segment. So if it's AC like that, that's a line segment, and you'd use the congruent symbol. If it's AC like that, that's the distance or length. So then you'd use the equal symbol. I know they pretty much look alike, but that's the difference. So if it's got a bar above it, then you need the squiggly part above the equal for it to be congruent. If it doesn't have that, then you use the equal, like it's equal to a number. Any questions? Okay, then on the left side it says alternate interior angles alternate interior angles theorem, and then it says, what does the word interior mean? Interior means inside or between. Inside or between. And so here what we're talking about in this context, it means between parallel lines. I'm just doing the symbol for parallel. Between the parallel lines. So again, as an example, this one and this one, with those lines parallel. Opposite sides of the transversal, and between the parallel lines. The next one says there's right angles, and so then it says, what is the measure of D? If it's a right angle, it'd have to be 90 degrees. Then they're showing you that it's congruent from HL. What information was necessary for HL? First, you have two right angles. So in this case, it would be angle B and angle D. The next one would be congruent hypotenuses. And so in this case, it'd be AC congruent to EC. And so make sure you put your bars above it as well as your congruent symbol. So that's your congruent hypotenuses, AC congruent to EC. And then your third one is one congruent leg.
Sorry, I didn't quite catch that. Could you please...
One congruent leg. So BC congruent to DC. All right, then we used CPCTC. So remember the part about what is CPCTC. What are the corresponding angles and sides? So for the angles, A equal E, angle B equal D, and angle C equal angle C. The problem with this last one is you don't know which angle C. So instead, you need to use angle ACB equal to angle ECD for this last one. Angle ACB equal to angle ECD. And you don't have to write this other one, but it'd be or angle BCA equal to angle DCE. The main idea is your middle letter has to be C in both cases. Okay, so any questions about your angles? Okay, then for your sides, we're going to have the first two to the first two like we did before. This is kind of like a review of how we did our corresponding parts. This is AB equal to ED, BC equal to DC, and AC equal to EC. So basically the first two to the first two, the last two to the last two, and your first and last to your first and last. Okay, so there's those. Now we're working on the Form K next. And basically the blank is this. To prove that the right triangles are congruent, you must prove that hypotenuses are congruent and that one leg is congruent. One leg is congruent. So then we have to use our given statements and put this stuff. So angle WVZ and angle VMX are right angles. So that's given. And then the next given statement is the WZ congruent to VX. So again, the first two are just from the givens. The third one, they want you to use reflexive, but just make sure you're looking at the correct triangles. So we have WVZ, which is that triangle, and VWX, which is that triangle. If you mark it darker like I did, you can figure out that VW is in both. And so that means we're going to have VW congruent to WV. They're reversing it because when you go one way, V is the right angle, and when you go the other way, W is the right angle. So reverse your letters, but it's the reflexive property. We've been using that a lot lately. So then that's your pair of legs that are equal, and we were given that our hypotenuses are equal. I'm going to put hypotenuse in here. I'm going to put leg in here. And so we're going to use the HL theorem and just put our triangle WVZ congruent to triangle VWX. So there's your proof. Any questions? Okay, so then it says look at exercise 1. If x is 54, what is z? X and z are there. Also think z is third and x is third, so they're going to be equal. So this would have to be 54 also, just like that one. And then it's saying if x is 54, what is VWZ? So in this case, you just need to do your 90 minus 54, and you get 36. If you want me to mark it in here, you've got 54 here, you've got 90 here, and so these two have to add up to 90, which means they're complementary, because you already have a 90 degree. So then that'd be 36. So again, that's because those are complementary angles. Okay, the next one says study those, and how else could you prove those triangles congruent without using HL? There's no side links given, but they want you to really think outside the box on this one. You would use the Pythagorean theorem a squared plus b squared equals c squared if you know sides, if you're given lengths. I'm just going to say lengths of sides. So remember, if it's a right triangle, you can use this if you know lengths of sides and it's a right triangle. I'm putting that part because I know sometimes students have the audio part on mute. So I think y'all would already know this, but for people doing it faster or whatever, yeah. Okay, any questions about that? Okay, the next part shows that the triangles already are congruent, and so you just got to figure out which ones are equal. This is a hypotenuse because it's across from the 90, and so is this because it's across from this 90. So we know x equal 2y. So you do have two variables. It's not equal to a number at this point. And then we need x minus 4 equal y plus 3. So that also has two variables, and so you can't just plug in numbers. In this case, I'd say plug in 2y for where x was. Get it to use the same variable. So I'm going to say 2y minus 4 equal y plus 3. So that's called using, well, it's using one variable. It's in terms of one variable. So then you can actually solve it. Subtract y, so you get y minus 4 equal 3, so then y is 7. And then x would have to be 2 times 7, which is 14. So 7 and 14. X is 14, y is 7. So remember, this is the main way we do things in geometry. If it were Algebra 2, you could have solved through other methods like graphing or substitution or elimination. But we mainly solve through substitution. Okay, so now on this one, set these equal. And so we have y plus 5 equal 2y minus x. And then the other one is y plus x equal x plus 7. So they're not trying to make this too hard. The top one you can't do anything with, but on the bottom one, if you subtract x to both, then it goes away and you get y equals 7. Okay, so we did figure out that y is 7 just because these cancel out. And so then we got to plug 7 into this other equation. So we get 7 plus 5 equal 2 times 7 minus x. And so then we get 12 equal 14 minus x. Then I would solve that by adding x to both sides. So you get x plus 12 equal 14, and then subtract 12, so x is 2. So x is 2 and y is 7. Okay. Then for this one, the leg or LL theorem says that if two triangles are congruent, if both pairs of legs are congruent, what theorem or postulate could be used to prove that's true? So let's think about what that would look like. These would be equal, and these would be equal, and it's saying it has to be a right triangle also. So you've got your little right angle symbol there, and so that would have to be side angle side. So make sure you have the drawing for the explain part. So tomorrow we'll work on the other side of Form K, and then you do the Form G.